All right, day two, solving exponential equations. Yesterday, we looked at that really important concept. In fact, I'm going to talk about it off to the side over here. That if I have something like this, 2 to the x equals 2 to the 3, then we can draw this conclusion that the exponents must be equal. If the bases are equal, the exponents must be equal, therefore x equals 3. And that's how we solve exponential equations. We call this equating the bases. Okay, so I make sure that the bases are same, and then I also equate the exponents. If the bases are the same, the exponents are the same. Another example, 5 to the x plus 1 equals 125. Well, I can rewrite 125 as 5 cubed. So one of the tricks to this is you do have to be able to figure out how to write these numbers in exponential form, right, as an exponent. And some of these you might know, some you might not, and if you don't, then you just will do trial and error kind of thing. Okay, so with my calculator, I would just go, well, 5 squared, I know that one's 25, so I probably wouldn't try that one, but it didn't work. And then try 5 cubed, and there's your 125. If it wasn't that, I'd go up another one, 5 to the 4, and keep going until I found the right one. But in this case, it's 5 cubed, and so then I say, therefore, x plus 1 equals 3. So the whole exponent equals the whole exponent, right? I equate the entire thing. And then in this case, I have to solve it. So I move the 1 over by subtracting 1 from both sides. And x equals 3 minus 1, which is 2. Okay, so that's the basics of how we did it. That's the fundamental idea of how this whole system works. And we did some that were, a little bit more complex, but it's always using this same understanding about the exponents in particular and how I can rewrite something that's not in the correct base, like this 125, rewrite it in the base that I want. And it would be a common question that people would have where they'd say, what if you can't rewrite it in the proper base? What if it was 126, which can't be written as a power of 5? Well, we're not going to see questions like that, okay? In applications, there will actually be some circumstances where we're just going to estimate it, but we'll talk about that when we get there. But for now, for all these, they're going to work out nicely. There is an operation that you can use to solve these when they're not perfect answers, but that's not something that we cover in this course. So the only thing we're adding today, we're doing some more practice, and then we're going to add on the formal check. Okay, and that is not different than stuff we've done in the past. It's the same idea. So let's get started on the first one. Solve each of the following and complete a formal check. I'm going to zoom in here. So I've got a base of 2 and a base of 4. And I have to rewrite one in terms of the other. So I can change a 4 into a power of 2. So this is 2 to the 3x minus 1 equals something to the x plus 2, right? And how do I rewrite 4 as a power of 2? Well, 4 is equal to 2 squared, 2 to the 2, right? So this is 2 squared all to the, and I like to put brackets around it like that instead of in a box, all to the x plus 2. And again, we did this yesterday. When we have a power of a power, so again, I'll come over here and I'll show this. So 5 squared all to the 3 is 5 to the 2 times 3, right? You multiply the exponents together, so it'd be 5 to the 6 in that case. But for us, I want it to look like this. 2 to the 2 times x plus 2. Okay, so when I have a binomial or some kind of expression in there, or any exponent for that matter, I end up having to multiply them. Sometimes I need those brackets because I am going to do distributive property. So that's a part of what we're working towards, as well as all those little details of how you do, the questions that have little nuances in them. This is a step that when we set the exponents to equal each other, we use the therefore symbol. It is kind of required. People probably think it's picky, but the reason why we use it is because there's not an operation that we're using to do this step. We're just concluding that if the bases are the same, then, the exponents have to be the same, right? So we're using this logic, and that's why we use the therefore symbol. So I would like you to try to remember to include it. And now I just have a simple linear equation that I'm going to solve. And for this one, I'm going to start by expanding. And you can't skip, don't skip too many steps. But if you wanted to go straight from this step, straight from this step to this step, that would be fine. So like you are equating the exponents and expanding at the same time. If you wanted to do that, that would be fine. You can shorten this up a little bit. I'm showing all my extra steps because I want to make sure everybody can follow everything. So minus 2x, I'm putting all the x's to the left, and I'm putting all of the numbers to the right. So I'm adding 1, because a -1 means I'm going to add 1. Okay, to get rid of it on that side, and that will move it to the other side. 3x minus 2x is just x. The -1 and the +1 are gone. The 2x minus 2x is gone. So those are gone and those are gone. And 4 plus 1 is 5. So x is 5. Okay. And that is similar to the questions we did yesterday. Now we're going to check. So we already hopefully know what a check looks like. So we're checking if x equals 5. So I just like to have an equal sign with a question mark through it because we're sort of asking if it's true. We're not stating that it's true. Okay. And we start with our left side equals 2 to the 3x minus 1. And our right side, which equals 4 to the x plus 2. And hopefully you remember that we have to separate the two sides. That is required for a formal check. You can't just write it the way we write it up here, like an equation. Okay. Then I sub in. So I'm checking if x is 5 works. So I'm putting 5 in for x. And I can do one sort of side at a time, right? Not do one step of each at the same time. But that's kind of how you set it up. We start with the left side and the right side, do our substitution, and then solve. So 3 times 5 is 15. That's 2 to the 14. And 4 to the 5 plus 2 is 4 to the 7. And now I'm going to need my calculator for each of these. And 2 to the 14 is 16,384. And 4 to the 7 is 16,384. And I don't need to show all those steps. I could just use the calculator and go 2 to the 3 times 5 minus 1. That would be fine. Oops, I did something wrong there. Oh, 2 times 5. Whoops. 3 times 5 minus 1, and that would give me the right answer. Okay. So I say left side equals right side, therefore x does indeed equal 5. Okay. I like to see separating them, left side and right side. I like to see the substitution step. Then you can go straight to the answer in one step with your calculator. That's fine. Question always comes up, what if they don't? What if the left side doesn't equal the right side? Well, it means you've either made a mistake here or you've made a mistake somewhere here, okay? And if x equals 5, if that's correct, then your mistake would be there. But if x doesn't equal 5, then your mistake is going to be over here somewhere. And you wouldn't necessarily know, so you're going to have to go through your work and find your mistake. If it's a quiz or a test, I always say skip it, move on, finish the rest of the test, leave it the way it is, and come back and find your mistake. So at least you've left an answer for the question and you're going to get part marks and you can finish the rest of the test. And if you have time at the end of the test, put a star beside the question, come back and spend some time looking for your mistake when you know that the rest of the test is finished. That's what I always say, because you're going to get part marks. But if the left side doesn't equal the right side, it does mean you got a mistake somewhere, so you should go back and find it. Okay? And that is that. That's today. More practice of solving exponential equations, and we're going to practice a little bit of this formal check as well. All right, so let's do another one. And right away, people might be thinking, what is going on here? What's going on? A 1, how do I do that? Because, for example, up here, the 4 could be written as 2 squared. Over here, 125 can be written as 5 cubed. And then I have the same base, which in this case was 5, on both sides, right? So I could do that with the number 125, but what do I do when it's a 1? Well, this is easier than you might think. And as I said, for this course, we are always going to be able to write them in the same base, okay? Now, we did see sometimes there are questions where I have to rewrite both the left side and the right side as a new base. Okay, we did see questions like that yesterday. In fact, here's an example right here where I had a base 4 and a base 8, and so I rewrote them both as base 2. Okay, so we have seen questions like that, but that's not what this one is. Okay, this one is, we have to remember that when I've got a 1, that's actually is going to make my life kind of easy. And what I want to just remember is I've got to be able to write them as the same base. So my base is going to be 3, and 3 to what exponent equals 1? Well, it's 3 to the 0, right? So there is a way that I can rewrite 1 as a power of 3, and it's 3 to the 0. So what you want to remember is just, oh, that's the 1, that's that weird case where I just have to remember that I'm using a 0. Okay, and kind of get used to recognizing it, because if you didn't really think about it, or if you didn't see this example, you might not be able to make that connection on your own. So you want to remember that we've done examples like this, and then it becomes easy because I'm already done, and I can just do 5x minus 7 equals 0. So add 7 to both. Add 7 to both sides, and x equals 7 over 5. And I got a fraction. And that's going to be okay. We are going to get some fraction answers. And in fact, we've done fraction exponents. So it might kind of make sense that we would have some fraction answers. So again, I'm going to do a check. Does x equal 7 over 5? The left side is 3 to the 5x minus 7. Minus 7. And the right side is just 1. So all my work in this case is going to be on the left side. And again, once I get to this step, I can just punch this into my calculator. That is totally fine. But I'm going to do the work. So this is 5 times 7 over 5. And I can divide those to 1. 5 divided by 5 is 1. So they're now have turned into a 1. So they're gone, basically. And this becomes 3 to the 7 minus 7, which is 3 to the 0, which is 1, which is the right side. So left side equals right side. Therefore, x does indeed equal 7 over 5. Okay, but again, I could just do 5 bracket 7 over 5 bracket minus 7 equals, and get 0, and so I would know it's 3 to the 0, or even better, if you really want, I can do 3 to the exponent 5 times 7 divided by 5 minus 7, oops, I didn't have a bracket, okay, equals, and it gives me the 1. So however you punch it into your calculator, just make sure you know what you're doing and that you have a system that you're comfortable with. But you do, again, as I'll repeat, you do not have to show those steps. I just like to because, you know, it's a good refresher. Mental math is a good thing to practice. But when it comes down to it, you want to do things quickly, you want to save time, and you want to get the right answer. So it's totally fine to use your calculator. All right, let's move on. We've just got a couple more to do here. C, 9 to the 3x plus 1 equals 27 to the x. So again, this is one of those ones where 27 is not 9 squared, okay? So I can't just rewrite, or I can't easily. I'll give you, you know, it is true. You can actually do it, but it would be really complicated. So we're not going to bother with that. It would be way harder than the way we're going to solve it. Okay, so I can't turn a 27 into a 9 easily, and I can't turn 9 into a 27 easily. Again, 9 squared is not 27. So I have to figure out some common base that I can turn them both into. And you know, you could list these on your own. Don't write these down. I'm going to erase this. But the powers of 2 are 2 squared is 4, 2 cubed is 8, and then 2 to the 4th is 16, to the 5th is 32, to the 6th is 64, and so on. What about 3? Well, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, and again, you could continue and write more and more and more, and you could do that for all of them. And I wouldn't go past 4 or 5 of these powers, okay? So for 4, it's 16 and then 64. Okay, so 4 squared is 16, 4 cubed is 64, and again it goes on, and I could do 5 as well. And you could list these out so that you can just see them. And I can see that both 9 and 27 are in the row for 3. So I can write both of those as powers of 3. But no matter what happens, you have to be able to come up with that number and be able to do that part. You probably know that 9 is 3 squared, and that would give you enough of a tip to say, well, if 3 squared is 9, how about I try 3 cubed, and it's 27, or 3 to the 4 if that didn't work, or 3 to the 5 if that didn't work, and keep trying until you find the one that's correct, okay? But we figured it out, it's 3, so I'm going to rewrite the 9. And again, I like to put that in brackets because it's going to be cleaner in my next step. And I'm going to put the 27, and I'm going to rewrite them both as a power of the same base. So this is going to be 3 to the something and 3 to the something, right? And I got whatever I make in this box will have to give me 9. And so, whoops. So that's going to be 3 squared. Actually, I'm going to put that box back. Okay, so I'm putting a 2 in that box. 3 squared is 9, and 3 cubed is 27. Okay. Now I have to use the exponent laws to do this part, multiplying the exponents because it's a power of a power. Then I can equate the exponents, set them equal to each other because the bases are equal. And again, remember the bases have to be exactly equal and no other junk. It can't be like a +1 or something like that. That won't work, but we won't really see that, so it should be okay. 2 times 3 is 6x, 2 times 1 is 2. And you know, if you do the practice and you're thinking about this and you're working hard at it, you're probably going to be really good at that part. And sometimes the mistake that people make is here in what should be the easy part, but it certainly isn't always easy. So, you know, watch for that. Make sure that you can do this part as well, because you don't want to do all of the new stuff and really nail that. And then your struggle is with this last part, right? So I am going to move the 3x to the left by subtracting 3x from both sides. And then I'm going to subtract 2 from both sides as well. 6x minus 3x is 3x equals negative 2. So I moved the 2 over and it became negative. Divide both sides by 3. And x equals negative 2 over 3. Finally, our check for this one equals negative 2 over 3. Left side, right side, 27 to the x, subbing in. And on this side, on the left side, 3 divided by 3 is gone again, so this becomes negative 2 plus 1. Okay, again, you could use a calculator to do that, but 3 times negative 2/3 gives me negative 2, which is 9 to the negative 1, and we know how to evaluate negative exponents. That's 1 over 9 to the positive 1, which is just 1 over 9. I probably wouldn't write that second last step there, but just reminding us the rules for dealing with negative exponents, because that's very important. With my awesome calculator, watch what I can do. 9 to the 3 bracket negative 2 divided by 3 bracket plus 1. And it's going to give me the fraction 1 over 9. And we didn't used to have calculators that could do this, so we had to be able to do this kind of work on our own, because our calculator would give us nasty decimals, which didn't always work for the stuff that we wanted them to do. Our calculators can do that now, so we can get by, especially if you have a calculator that will give you the fraction answer, that's fine, but we do want to get that fraction answer. I'll do the same thing here. This is 1 over 27 to the positive 2/3. And now this is where what we were just doing a few days ago, rational exponents, so fractions as exponents. And remember what this means is the denominator, if this is 2 over 3, the denominator goes into the root symbol, and the numerator, the 2 that was on top, becomes the exponent. So I want to do, it might be easier actually for me to do it like this. Let's do it both ways. Let's do it both ways. I'll leave that. 27 squared. So 27 squared, I just can't do that in my head, is 729. Cube root of 729. And the cube root of 729 is going to be 9. So this is 1 over 9, which is what we expected, right? I could have written this as 1 over cube root of 27 all squared, right? The squared can go inside the root symbol or outside. Cube root of 27 is 3. 3 squared is 9. So if I had done it in that order, I could do it in my head without my calculator. Either way, you could also punch that straight into your calculator. 27 to the negative 2 divided by 3. And that's going to give me the answer that I need. Okay, so either way, we got them balanced. So negative 2/3 was the correct answer. Okay. Last one. Ooh, this is a little strange. So this is 2 to the negative 4 minus 10x equals 1 over 512. Now, a couple things we have to notice here. When it's a fraction, we immediately have to think we're thinking here negative exponents. That's negative exponents cause fractions. So if I see a fraction, I want to think about a negative exponent. And I am going to need a base of 2. So I'm going to start checking. Well, 2 to the 5, 2 to the 6, I kind of know those ones. So I'm going to try 2 to the 7. Nope. 2 to the 8. Nope. 2 to the 9 gives me the right answer. So if 2 to the 9 is 512, then 2 to the negative 9 is 1 over 512, right? So there's a couple ways that you could do this. The order doesn't necessarily matter. This is 2 to the negative 4 minus 10x equals 1 over 2 to the 9. So rewrite the 512 as a power of 2 because I'm matching the base. And then realize that I need this to go up to the top. So it's going to be 2 to the negative 9. I can't leave it like this. I've got to add in that negative. Or if you're really comfortable and you think you can go straight to that because you know it's just going to be a negative, that's okay too. This is something that can be tricky. It might make sense when you're following me doing it, but it can be very tricky. So really want you to make sure when you're doing the practice that you're trying those ones and you're able to come up with that proper step there. Okay. And it all just comes down to that relationship of negative exponents. So think about this if you have to, and remember the basic idea of negative exponents before maybe trying to make sense of that part. Okay, so what am I going to do here? How about I add 4 and add 4. Negative 10x equals negative 5. Divide by negative 10, divide by negative 10. The negatives cancel to a positive, and 5 over 10 is 0.5 or 1/2. We don't want to have, like if this was 2/3, I don't want that to be 0.6666. I don't want to turn that into a decimal. So I'm going to leave it as 2/3. But for this one, if I did 5 divided by 10 and got a decimal of 0.5, that's fine because it's not rounded at all. So that one would be fine. And finally, our check for this one. And what was the left side? There it is, 2 to the negative 4 minus 10x. And the right side was just 1 over 512. So again, I don't need to do anything to the right side. To the positive 1/2. 10 times a half is 5. So minus 5, which is 2 to the negative 9. And all that stuff that we already did, like I've got it written right there. I've already kind of gone through this thinking, so I know that this is 1 over 512 because it's 1 over 2 to the positive 9, which is 1 over 512. Okay, and finally, left side equals right side. Therefore, x is 1/2. And that's that. That's it. We're doing 4 examples today. All we're doing is adding in the check. Otherwise, we saw most of those kinds of things yesterday. But being aware of when you have a fraction and you have to introduce negative exponents, okay, being aware a little bit of fractional exponents and evaluating them like we did over here in the check, but you can kind of cheat on that one with your calculator, especially if you have a good calculator. And the other one that we saw that's a bit different is, remember these ones that have just a 1 on one side, but we can write that as anything we want to the power of 0, right? We can write whatever we want. 5 to the 0 is 1, 10 to the 0 is 1, whatever we want, but we chose 3 because the left side had a base of 3. Okay, and that's that. Careful of those checks, but that's something we already know how to do, and otherwise more practice of solving exponential equations.